Hello everyone, today me along with my teammates are here to present our presentation on scheduler performance analysis in distributed computing. The flow of presentation starts with introduction and to objective and about Apache Spark and job schedulers and finally on results and conclusion. So here we begin.
Apache Spark is a powerful open source unified analytics engine for large scale data processing. It is one of the most prominent tools for big data processing catered to handle both real-time and batch data. It operates on master-slave architecture where the driver program acts as the master, managing the application workflow. The driver program communicates with cluster manager, which can be Spark's own standalone cluster manager, Hadoop Yarn, or Apache Mesos, to allocate resources across applications efficiently. Worker nodes or slaves execute the tasks assigned by the driver within their JVM instances. Spark introduces the concept of resilient distributed datasets, which are fault-tolerant collection of elements that can be operated on in parallel. RDDs are keys to Spark's ability to handle both batch and real-time analytics, providing a simple programming interface that allows for operations like map, filter, and reduce across clusters.
Let's look into job schedulers now. A job scheduler manages and optimizes the distribution and execution of tasks effectively in the environment. In Apache Spark, there are two scenarios, scheduling across application and scheduling within an application. In scheduling within an application, there are two schedulers under discussion now, FIFO and FAIR schedulers. The first in first out FIFO scheduler in Apache Spark is a fundamental component responsible for task allocation and execution within a Spark application. And on the other hand, the FAIR scheduler in Spark allows resources to be allocated fairly among all running jobs, preventing any single job from monopolizing cluster resources. Going a bit deep more into FIFO operating on a straightforward principle, it prioritizes tasks based on their submission time, ensuring that the earliest submitted tasks are processed first. When a new task arrives, the scheduler assigns it to an available executor, and then the task is executed in order it was received. The sequencing guarantees that the tasks are processed in the same order they were submitted, maintaining a strict adherence to the FIFO principle. Under the hood, the FIFO scheduler manages task queues for each Spark application, organizing tasks based on the priority determined by submission time. As tasks are completed, the scheduler assigns resources to the pending tasks in the order they were queued. While FIFO scheduling provides simplicity and predictability, it may lead to potential inefficiencies in resource utilization, especially in scenarios with varying task execution times or resource requirements. Despite its limitation, FIFO scheduler serves as a foundational mechanism in Spark, offering a clear and intuitive approach to task scheduling and execution.
Coming to FAIR scheduler, in Apache Spark, FAIR scheduler ensures equitable distribution of cluster resources among multiple applications. It operates on the principle of fairness, dynamically allocating resources based on the current workload. Utilizing a hierarchical structure, it organizes jobs into pools, facilitating fine-grained control over resource allocation. Preemption is a supported feature, allowing resource to be reclaimed from low-priority jobs for high-priority ones. FAIR scheduler continuously adjusts resources dynamically and seamlessly, integrates with Yarn and standalone mode, making it an indispensable tool for optimizing the resource utilization in Spark clusters. Within the cluster, the FAIR scheduler ensures equitable resource allocation among jobs by maintaining resource queuing jobs, allocating resource fairly, dynamically, and adjusting resources and reallocating resources as necessary to maintain the fairness in the cluster.
We have 15 workers alive right now, and let's put these workers in job using Spark session. Let's run this FP growth algorithm using FAIR scheduler. It takes a little bit of time, and let's wait for the results. Yeah, finally it got completed, and you can see all the results here with the best hyperparameters of minimum support 0.2 and minimum confidence 0.1. Total time it taken of 0.4 minutes. Yeah. This is the DAG visualization of FP growth algorithm using FAIR scheduler. First, it's going to parallelize the datasets and all the jobs assigned and map partition to the nodes, and all the process is completed. Nodes will map back to the master to give all the results to the master, and then it's done.
Our extensive experimentation revealed the complete advantage of FAIR over FIFO scheduler for both small and moderate number of nodes and for both algorithms random forest and FP growth. While the magnitude of this advantage varied across the number of nodes, this can be attributed to the network overheads that occur. Further study needs to be done to study and quantify this effect of these overheads for a more detailed results. Thank you.